Okay, you guys, we've got our second to last video for the chapter. We're now doing limits approaching infinity and involving infinity. So we've been doing limits so far approaching a certain number like 2 or 0 or -1. Now we're going to be looking at infinities. And what's really important about this section, again, this whole chapter has so much Algebra 2 review in it, but we need to spend a decent amount of time reviewing how to graph a rational function. So if you remember, this was an entire chapter in Algebra 2. How to graph a function that is a fraction like this is called a rational function. And we have a bunch of asymptotes, and your graph looks like little boomerang sections that approach the asymptote. So let me go really slowly through how to figure out what the graph of this looks like. Because again, once you get the graph sketched, answering any limit question is very, very simple. So the first thing you're going to want to do is figure out what this thing called the vertical asymptote is. Remember, an asymptote is a dotted line that your graph is like attracted to. It approaches, but it doesn't touch it. So we have a dotted line somewhere on this graph in a vertical fashion. And the way you do that is you set the denominator equal to 0. So in this case, our denominator, x minus 3, when you equal it to 0, you get x equals 3. That is the asymptote. Make sure that you don't just write the number 3, that you actually write the equation x equals 3. I am picky on that because we need to differentiate between a vertical line and a horizontal line, which I'll talk about in a second. So anyways, the very first thing I'm going to do is I'm going to graph x equals 3 as a vertical line. And I like to put it in like red or highlighter or like some sort of a different color. So I have an asymptote on my graph that looks like that. That is the first thing I'm going to do. Now let's talk about the horizontal asymptote. Again, this is review from Algebra 2. You guys all were very successful in Algebra 2, which is how you made it to advanced trig and pre-calc. This was an entire chapter towards the end of the year that you did in Algebra 2, but I need to refresh your memory on those concepts. How do we figure out what the horizontal asymptote is? So there's also a horizontal dotted line somewhere on this graph. There are 3 scenarios that you need to be aware of in order to figure out what the horizontal asymptote is. And remember, horizontal is a y equals, vertical is an x equals, so the actual equation is important, not just the number. Anyways, in this case, if your degree of the top is less than the degree of the bottom, what do I mean by degree? Do you remember the degree? It's the highest exponent on any x of the numerator. So since there's an x term here and this is just a constant term, the degree of the numerator is just 1 because this x has an exponent of 1 on it. The degree of the denominator is also 1 because this x has an exponent on it. In this case, the degree of the top is equal to the degree of the bottom, and that's why we do y equals the lead coefficient of the numerator. So the lead coefficient here is 2. Remember, if you line up all of the terms, if there was like an x to the third, x squared, x to the fourth, whatever, you have to line them up in decreasing order. And the lead coefficient in this case is 2. The lead coefficient down here is 1, the coefficient on the x value. That's why I'm doing 2 over 1, which is 2. So the degree of the top is equal to the degree of the bottom. That means that the y is the lead coefficient of the numerator divided by the lead coefficient of the denominator. This equation falls into this 2 category. Looking down here at this one falls into the number 1 category. The degree of the top here is 0 because there is no x term, so technically you can think of that as there being an x to the 0 in the numerator. And then the denominator has an x to the first. So the degree of the numerator is 0 and the degree of the denominator is 1, and so that makes it fall into this category. This one has a horizontal asymptote of y equals 0. And then the third case is, what if the degree of the top is greater than the degree of the bottom? This should be a greater than symbol. Sorry. Degree of the top greater than degree of the bottom. For example, what if my function looked like this, x squared plus 3x minus 4 over x minus 1, something like that. The degree of the numerator is 2 because the highest exponent on x is a 2 here, and the degree of the denominator here is 1, so the top is bigger than the bottom. In that case, that's a third case scenario, and that's when you have a slant or an oblique asymptote. It's not horizontal, but it's like a slanted line. We're going to use synthetic division in that case. We won't do many examples that have to do with scenario number 3, but in case you were wondering, and if you remember that from Algebra 2, that is that. Anyways, okay. So I need to do my dotted line for y equals 2 here. Again, the degree on the top was 1 and the degree on the bottom was 1, so that makes it fall into the second category. Y equals the lead coefficient over the lead coefficient, which is how I got 2. So at 2, I am going to put a horizontal line. So it's really important that you make sure that you don't mix up like the horizontal and the vertical lines, okay? So those are my asymptotes, and those are the really helpful and important parts of what the graph of this function looks like. And from here, what I'm going to do is just make a really simple t-chart to figure out what the rest of my graph looks like. And so you know how I have an x asymptote, a vertical asymptote at 3? So that means I want to pick a couple points, like 1 point on the left of 3 and 1 point on the right of 3. So whatever your horizontal asymptote is, I always like to put that into my t-chart. And then you have to pick a point on the left and the right of it so you have an idea of what's happening over here in the graph and also what's happening over here in the graph. We have 2 sections of graph here, so I need points on this side and I need points on this side. That's why I always put the vertical asymptote number right in the middle. And if you plug in 3, remember you get undefined. That's why there's an asymptote there. Okay, so we're not actually going to have a point at 3 because I already have a dotted line at 3. But that helps me remember, okay, I should probably plug in 2 and I should plug in 4. So I'm going to plug in 2 to this equation, the numerator and the denominator, and I get 7 over -1, which is -7. What happens when I plug in 4? Plugging in 4 to here and here, I get 11 over 1, which is 11. So those give me 2 different ordered pairs. And I'm not going to be super picky because 11 is like really high, way up here. I don't have a huge graph, and also -7 is pretty low. But what that does is that tells you where the graph is located. That means that my little boomerangs go like this and like this. So the point 2, -7 is like, I don't know, way down here somewhere. And so that tells me that this part of my graph is underneath the horizontal asymptote, not above the horizontal asymptote. How do I know there's nothing up here? Because you guys remember these are supposed to be functions. If you draw a vertical line through your graph anywhere, it should only hit the graph 1 time. That means that if my point right here, 2, -7, that's somewhere down here, that means my little boomerang shape goes down here. That means there is not a boomerang shape up here. Similarly for 411, so the point 411 is like way up here somewhere. That just tells you where your little boomerang shape is supposed to go. Having the asymptotes there helps you with the majority of the graph. You just need a point to be able to tell you, does this boomerang go up here? Or sometimes there's a boomerang that goes down here. You cannot have one here and here because that would not make it past the vertical line test. If you wanted to, or if you were like nervous or confused or whatever, you can pick more points for x, like maybe 2, -7. What happens when you plug in 1 or 0 or -1? That would just give you more points that you could connect to help you feel more confident about your graph. If this 411 was kind of freaking you out, okay, so pick another point. Pick 5, pick 6, pick 7. That would just be forming this little boomerang shape, and you'll see that it is getting really, really, really close here to the y value of 2. Okay, so let's try another example down here using those same strategies that we just talked about. I want to kind of get a little bit of a sketch of what this graph looks like so that I can answer these limit questions down here about it. Okay, so first of all, the first thing you do is you figure out what the vertical asymptote is. Remember how to do that? You take the denominator and equal it to 0. So there's nothing to solve there, so you just get x equals 0. I'm going to put a dotted line right here on my axis. Just remember, don't put that on the y-axis. This is a vertical dotted line because it's x equals 0. What about the horizontal asymptote? It's y equals, and in this case, the degree of the numerator is less than the degree of the denominator. There is no x term up here, so technically that means the degree is 0, and the x term down here has a 1 exponent on it. So the degree of the top is 0, the degree of the bottom is 1, and that falls into this, which category? This category, number 1. When the degree on the top is less than the degree on the bottom, that means y equals 0 is your horizontal asymptote. So again, I'm going to put y equals 0 dotted line right there. Now let's figure out our t-chart. Remember that there's an asymptote. The vertical asymptote is at 0, so I want to pick points to the left of that and to the right of that. You can pick more points if you wanted to. You only need one of them because the asymptotes help you graph. This should be kind of coming back to you from Algebra 2 now. When you plug in -1 to this equation, 1 over -1 is -1. When you plug in 1 to this equation, 1 over 1 is 1. So -1 is right here. That tells me that this little boomerang shape looks like so. Again, if you wanted to pick -2, -3, -4, and pick more points, those would just be connecting your boomerang and helping you figure out what the shape is. When I plugged in 1, I got +1, so that was here. This boomerang shape goes right there. Again, how do I know that there's nothing right here in this quadrant? If there was, that would not pass the vertical line test. That would be a fail. It wouldn't be a function. How do I know there's nothing down here in this quadrant? Again, if there was anything down here, it would not pass the vertical line test. Now that I have my graph graphed, that was really quick and simple because it's a very, very basic rational function equation. Now I can start analyzing these limits. So what happens as I'm approaching 0 from the left? So my roller coaster is approaching 0 from the left. You tell it's getting closer and closer and closer and closer to, what's the y value down here? I know you're thinking the x value is 0, but remember you're reporting the y value. Where is my hand going if I'm at the board and I am tracing this? What y value do I end up at? You can tell that I'm going down and down and down and down and down forever. That means I'm approaching -infinity. This is why this whole section is on like limits approaching infinity. So just remember that when I give you the x value, you are supposed to give me the y value. As this x value approaches 0, here's an x value of 0, I'm getting closer and closer and closer. The y value is decreasing forever. That means it's approaching -infinity. As I'm approaching 0 from the right, so I've got my right hand now and I'm riding along this roller coaster and I'm getting closer to x equals 0. Where is my hand going? I can't even reach that high anymore. It's going up forever. That means it's approaching +infinity. Therefore, the limit as x approaches 0, that means that since it's not having a plus or a minus here with the 0, I have to look at both sides. This side was approaching -infinity. This side was approaching +infinity. Since those are not the same, the limit does not exist. My hands do not meet. One hand is going down forever, one hand is going up forever. My hands don't meet, that means it just does not exist. I think what a great idea for you to do right now would be to pause the video and try sketching example 2, 3, and 4, because I'm going to pause them and sketch them so that I can go a little bit faster through working through them, but you should check to see if you think you remember how to graph these. So pause the video and graph them and then check your work with mine. So here's what the graph for number 2 looks like. So really quickly, remember for the vertical asymptote, you're setting the denominator equal to 0, and that gives you 3/4, and it's x equals 3/4. It's a vertical line. Even though it's not a whole number, that's okay. You can still sketch it. There's my tick mark for 1, just a little bit less than that. 3/4 is 0.75. Horizontal asymptote, so the degree on the top is 0 because there is no x term. The degree on the bottom, the exponent here on the x is 1. So therefore we're using that case number 1 from above. It's y equals 0, so my dotted line went at y equals 0 there. And then to make my t-chart, remember, put the vertical asymptote number right in the middle, and you have to pick a number on the left and on the right. They don't have to be fractions. They can be any numbers you want. It's just supposed to figure out like if the boomerang is supposed to go above the horizontal asymptote or below it. In this case, when I plugged in 0, because that's a number less than 3/4, and it's super easy to plug into any function, when I plugged in 0, I got 1/3. So 0, 1/3 is right there. The boomerang is above the asymptote. When I plugged in a number to the right of 3/4, I just picked the whole number 1. When I plugged in 1 here, I got -1. So here's 1, here's -1, put a dot there. This boomerang goes like that. There is no boomerang down here because that would make it not a function. It wouldn't pass the vertical line test. There's also nothing up here because, again, that wouldn't pass the vertical line test. So now we can analyze the limits really, really quickly. Think about your left hand and your right hand. Just make sure you remember that you're reporting the y value when I ask you for the limit. So as the x value approaches 3/4 from the left, remember 3/4 is the vertical asymptote. So my left hand is traveling, 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 and then it skyrockets up to positive infinity. My left hand goes up forever. Remember the x value is 3/4, but what's the y value when it is way up in the sky? It's infinity. As x approaches 3/4 from the right, so I'm traveling from the right towards 3/4, and I end up going down forever. So that means negative infinity. And again, that means that as it approaches 3/4, it does not exist because this is going up, this is going down, my hands do not meet. That means the limit does not exist. Here's what the graph of number 3 looks like. So this one is a little bit different just because the boomerangs aren't like catty corner from each other. I don't know why I call these boomerangs, I just do. Okay. Anyways, let's do our vertical asymptote. Remember, you set the denominator equal to 0. So even though it's squared, when you square root both sides, you still get 0. That gives us x equals 2. So vertical line, dotted line at x equals 2. Horizontal asymptote, the degree on the top is less than the degree on the bottom, so that falls into category number 1 from above. That means y equals 0, so there's that dotted line. And then when you make your t-chart, remember the x value of the asymptote goes in the middle, and then pick a point on the left and a point on the right. When you plug in 1 to this equation, because it's -1 squared, it's +1. So this point right here tells me that this is where my boomerang goes. I also know there's nothing down here then, because that would make it not a function. When I plug in 3 here, I also get 1. So therefore 3, 1 is right there. This boomerang is up here too. And so this is a different scenario just because our denominator here is squared. That means we're always going to have positive numbers and nothing negative. So if you're wondering why that has a different shape, it's because of the square right here than the other ones that we've done so far. Anyway, so let's go ahead and analyze the limits. As x approaches 2 from the left, so my left hand is approaching 2, I'm going up this roller coaster and it is going into the sky forever. Remember, you're reporting the y value. It's positive infinity. What about my right hand? So my right hand is approaching 2. It's getting closer and closer and closer to the x value of 2. The y value also continues to skyrocket. So that's also positive infinity. Therefore, we just looked at our first example where the limit actually does exist. It approaches infinity. So that is super exciting. Remember, the limit for your left hand and your right hand have to be the same in order for the limit to exist. My two hands are meeting up in the sky. Positive infinity. Those are the same from the left from the right, therefore the limit exists. All right, so here's our last one. In this case, for the first thing we do is we do the vertical asymptote. You set the denominator equal to 0, and so when you put x plus 3 equals 0, that gives you x equals -3. There's your dotted line for your x. There's your vertical asymptote. X equals -3. Make sure you've got x equals and y equals. The horizontal one, this is case number 2 from above, so the degree on the top is 1 and also the degree on the bottom is 1. Therefore, you take the lead coefficient. So the coefficient of x here is 1, and the coefficient of x in the denominator is also 1. 1 over 1 is 1. And so that's why we have a y equals 1 in this case as our horizontal asymptote. So once you get those dotted lines on there, you just have to make your t-chart. Your vertical asymptote, the -3 goes right in the middle. We have an asymptote there, so you can't plug it in. It's undefined, but you can plug in -2 and -4. In this case, when I plug in -2, I get -6, so that's down here. That tells me this boomerang is in this quadrant. When you plug in -4, I get 8, which is way up here. I didn't even count it out. It's pretty high, but it tells you that this boomerang is over here. How do I know there's nothing here? It wouldn't be a function then. How do I know there's nothing here? It also wouldn't be a function. So let's analyze the limits really quickly as x approaches -3 from the left. So my left hand is skyrocketing. That means it's approaching positive infinity. My right hand, as x approaches -3 from the right, the roller coaster is approaching -3 from the right, and it is going down forever. So it's approaching negative infinity. Again, positive infinity and negative infinity are not the same thing, so this one is again D and E. Thanks for watching. I will finish this part, you guys, in the next video, which is the last one for the chapter, so make sure you send me or your teacher your questions and give that worksheet a try, and we will talk to you soon. Thanks for watching. Have a great day.